Hey there guys. In this video, what we're going to do is we are going to look at a set of sample problems that are pretty similar to what you're going to see on the final exam. And the purpose of this exercise is just ask, what would you do if you actually came across this particular problem? So we're going to be looking for context clues, wording, that kind of gives us an indication of where this problem would be. So what I would suggest that you do is you maybe have a notebook ready, and as we go through each of the problems, which are numbered, just write down the keywords and things that I identify. So for example, if we're on number 3 and I say, well, this is a hypothesis test for these specific reasons, then that's what you jot down in your notes. So there are, I think, 41 problems in this particular set. So this might be a little bit of a longer video, so don't panic if that's the case. And we'll get through it. Of course, you have the ability to fast forward and that kind of thing if you need to. So again, it's really just dealing with looking at keywords, expressions or phrases, looking for the formula you might need, identifying vocabulary, describing the steps, etc. So again, in your notebook, make sure to number the problems for easy reference so you can come back to these a little bit later. And what's nice is that all of these problems do have answers, the solutions, so you can actually go back and work them if you want to later on. And so it's all posted on the Canvas website for you. So that's the good news. So let's get started here. So problem number 1 says, in the long run, which plan has the higher payout? So in this case, the keyword here, keywords, is long run. And so that means we are actually doing a comparison. So this means we are computing an expected value. So this would be a section 5.1 problem. So you're using that expected value. So again, the keyword here is the long run. Number 2 says we've got a new vaccine is being used in the laboratory experiment to investigate whether it's effective. We have 211 subjects in the study, and it says, is there sufficient evidence? So that's indicative of a hypothesis test right there, that words. Is there sufficient evidence to determine if a vaccination and disease status are related? Okay, guys, when you see that word related, that means an association. Okay, so hypothesis test that deals with association, that's chi-square test for association. That's section 10.7. And look at the table that they give us. This is a two-way table. Okay, so that's further evidence that this is a section 10.7 problem. Okay, so what you do is then is use all of your hypothesis testing steps and everything for section 10.7. So remember, we're not solving these things out. We're just looking at what the key words and phrases are that tell us what we would need to be doing here. And of course, the section. All right, number 3 says we've got a table that gives the list price and the number of bids received for 5 randomly selected items sold through online auctions, and we need to find the value of the coefficient of determination. Okay, coefficient of determination is the key word. That is chapter 12, and that's actually r squared. Okay, so we would actually need to know what the correlation coefficient is first before we can actually compute the coefficient of determination. So you got to compute r, and then you can square it and gets the coefficient of determination. In this one, we want to identify the sampling technique. So this is vocabulary. Okay, that's vocabulary. And so this is actually a chapter 1 question. So interviewing each member of the group you wish to study. Since we're interviewing everybody, it's a census. Okay, so it's chapter 1, just some vocabulary here. So nothing too crazy. In this one, we want to determine the graph that correctly represents the data. Okay, so we've got an age here, and we've got a bunch of ranges. Another name for those ranges is a class. And we've got frequencies. So the only thing that we use a frequency distribution to graph would be a histogram. So this would be a chapter 2 problem here. So again, looking at the ages, those are the classes, and the frequencies, frequency distribution, chapter 2. For the following type of data set, would you be more interested in looking at the mean, median, or mode? And state the reason. Okay, so this is going to be chapter 3. That's where we talked about the mean, median, and mode. So remember, the mean is best used for data without outliers, quantitative data. The median is best used for quantitative data with outliers, and then the mode is best used for qualitative data. Coordinator is going to select 6 songs from a list of 11 songs to compose an event's musical entertainment lineup. So how many different lineups are possible? Okay, so this is a counting question. That comes from section 4.4. So you got to ask yourself whether or not the order of the songs actually matters, because that means if it does, it's a permutation, and if not, it is a combination. So please keep that in mind. So it's section 4.4. Number 8 says, suppose we've got a large shipment of microwave ovens, contains 7% defectives, and a sample of size 300 is selected. What is the probability that the sample proportion will differ from the population proportion by less than 3%? Round the answer to 4 decimal places. Okay, so you heard as I was reading that I paused in certain places, so we're looking here for the probability of the sample proportion. That's chapter 7. Okay, probability of a sample. And this other keywords here, will differ from the population proportion by less than 3%. That means area in between. So make sure you go back and you look at that phrase that was first introduced, I believe, in chapter 6. Okay, that differs from the population proportion by less than 3%, or differs from the mean. So make sure you go back and review that particular phrase. I might be wrong. It might have been in chapter 7. That phrase differs from, but it means area in between. And probability that the sample proportion, that's chapter 7. Okay, we've got an engineer here, designed a valve that will regulate water pressure on an engine. The valve was tested on 110 engines, and the mean pressure is 4.7 pounds per square inch, or PSI. Assume the population standard deviation is 0.8. If the valve was designed to produce a mean pressure of 4 5/10 psi. Is there sufficient evidence? There it is. Is there sufficient evidence? So that's a hypothesis test at the 0.02 level of significance. That's what that's indicating. That the valve does not perform to the specification. So this, ladies and gentlemen, is a hypothesis test with means, okay, because we've got the word mean pressure in there. Okay, so this would be section 10.2, and you'd follow all of your steps for the hypothesis test. This one says find the average outcome. Okay, looks like some of the variables might not have transferred over here in this version of PowerPoint. That's okay, because we got the key words here. Average outcome means expected value, just a different way to say it. Section 5.1. So you multiply each of the probabilities by the sample, or sorry, each probability by the outcome. Mixing up my words here. We've got 50% of the population are more than 6 feet tall. If a random sample of size 780 is selected, what is the probability that the proportion of persons more than 6 feet tall will be less than 48%? Round the answer to 4 decimal places. So what is the probability that the proportion of persons, this is dealing once again with chapter 7, and of course we've got a sample size as well that is indicative of that. So keep that in mind. You're given a sample size, we're also dealing with chapter 7. Okay, another random sample of 7 residents of the state of California. The mean waste recycled per person per day was 1.8 pounds with standard deviation of 0.15. Determine the 99% confidence interval. Okay, I don't have to say anything more. Very clear what we have to do here. 99% confidence interval. And this is confidence interval dealing with means. So this one's kind of nice and clear what exactly we have to do. So this would be section 8.1. Suppose we have 46% of the doctors in a hospital are surgeons. If a sample of 795 doctors is selected, what's the probability that the sample proportion, there's that wording again, okay, will be greater than 44%? This is chapter 7, probability of a sample proportion. We've got a sample size there. And then they're asking us about it being greater than just means area to the right. Okay, suppose SAT mathematics scores are normally distributed with a mean of 515 and standard deviation of 115. University plans to send letters of recognition to students whose scores are in the top 10%. What's the minimum score required for a letter of recognition? This, guys, is not asking about a probability, but they are telling us we've got a normal distribution. There's no sample size here, but we've got a mean and a standard deviation. And we want to know what the minimum score is. This is a section 6.4. Do you remember those where we had the x equals z sigma plus mu? Okay, where we're looking for the x. That's what this question's asking for. So this one's a little bit tricky. So don't forget about section 6.4, where we kind of work in that process in reverse, trying to figure out what exactly was the value of that random variable. So section 6.4. And of course, let me go back for a second. Top 10% means area to the right is 0.1. So that means the area to the left is 0.9. And so you got to look that value of z on the normal distribution table to keep going with that one. So don't forget about how to do that. Okay, we got a box that contains marbles, large and small, and they're either green or white. So they give us some numbers here. It says if a marble is randomly selected from the box, what's the probability that it is small or green? Okay, it's a probability question, and we're looking for small or green. The key word there is or, so we're adding probabilities. So this is chapter 4. The question is, can we have a marble that is small and green? And the answer to that is yes. So make sure you use the correct formula from the formula sheet. So this one's not so bad, but make sure you're looking for the word or, okay, which means add the probabilities. Amy's looking into investing, okay, and she's researching different companies, and we've got different standard deviations here. And so it says, based on the data and assuming the trends continue, which company is going to give Amy a stable long-term investment? So this is just an analysis of standard deviation, which is coming from Chapter 3, I believe Section 3.2, with measures of dispersion or measures of spread. And since she wants stability, she wants less variation, which means she's going to pick Masterful Pocket Watches as the company for the investment because it has the smaller standard deviation, which means less variation, therefore more stable long-term investment. For the graph shown below, determine which letter represents the mean, the median, and the mode. This, ladies and gentlemen, is Chapter 2. Okay. I'm sorry, Chapter 3, because we're talking about means, median, and the mode. I'm looking at the shape here, the shape we talked about in Chapter 2, but this is pertaining to Chapter 3, because that's when we introduced mean, median, and mode. Okay, so Chapter 3. A little bit of Chapter 2, because you have to know the shape, and that can kind of help us. So don't forget about problems like this, where you have to identify those measures of center on the distribution here, again in Chapter 3. Given the data below, what type of graph would you use to display the data? Okay, so this is a Chapter 2 question asking about the types of graphs, and we've got a table here, and the item is listed: rent, food, car, entertainment. Ladies and gentlemen, those items are categories. So you've only got 2 graphs that we use for categories: bar graphs and pie graphs. Okay, so which one is suitable? Well, look what the other column says: percent of income. So they already give us the percents, therefore a pie graph would be best to use here. Point of the game is it's Chapter 2. Don't forget to understand what those variables are. Take a few minutes to take a look at the chart itself and understand. Okay, identify the population being studied and the sample chosen. That's Chapter 1, guys. More of your vocabulary. Okay, so make sure you're familiar with being able to understand the population versus the sample. When conducting a single masked experiment, or you could say single blind experiment, a scientist should not apply a process to produce a desired response to the, this is again more vocabulary coming to us from Chapter 1, where we talked about experimental designs. Write out the sample space. That's Chapter 4, guys. I don't have to read any more of the problem. Asking for a sample space is Chapter 4. So they give us some letters and things here. It might be easy to use your tree diagram, okay, when they're giving us a whole bunch of choices, so don't forget about that. But I'll leave that for you to read. Again, the purpose of this exercise is just to see what are the key words and phrases, but I don't have to go any further because it's very clear. Write out the sample space. Don't forget about your tree diagram. Mean cost of a 5-pound bag of shrimp is $40. Standard deviation of $8. If a sample of 51 bags of shrimp is randomly selected, what is the probability that the sample mean? This is Chapter 7. They tell us we've got a random sample of 51, and we were looking for the probability of the sample mean. Very clear. Box contains 77 marbles, red marbles, 6 white, 94 blue. If a marble is randomly selected, what is the probability it is red or white? This, ladies and gentlemen, is Chapter 4. There's your key word or, which means to add the probabilities. Okay, and so the question is then, can we have a marble that is both red and blue? So think about that because they're very specific in what we have here. And again, that helps you to determine which of the two formulas you have to use. But again, coming from Chapter 4, adding probabilities. Shoe sizes of American women have a bell-shaped distribution. Okay, bell-shaped means symmetrical. Mean of 8.11, standard deviation of 1.46, using the empirical rule. I don't have to say any more. Very clear what we have to do. Empirical rule was introduced to us in Chapter 3. So if you're still having trouble with empirical rule, make sure you take a look at the separate video that was created with some additional problems regarding it. Okay, so again, coming to us from Chapter 3. Identify the sampling technique. That's Chapter 1. More vocabulary for us. Okay, more vocabulary. We've got horses in a large stable have a mean weight, 992 pounds, standard deviation of 141 pounds. What's the probability that the mean weight of the sample of horses would differ from the population mean by greater than 13 pounds if 37 horses are sampled at random from the stable? My goodness, that was a mouthful. Okay, we know we have a sample, okay, 37 horses, and we want the probability that the mean weight, that means Chapter 7. Okay, probability of the sample mean. And look at the phrase here, would differ from the population mean by greater than 13 pounds. That means area in the tails. So remember, if it said the population mean differs from the population mean by less than, that would mean area in between. And I think we had language similar to that, but I think it dealt with proportions in an earlier problem. So don't forget about that phrase, the area in between and area in the tails. But this one coming to us from Chapter 7. We had plenty of practice with the differences between Chapter 6 and Chapter 7. Okay, this one's a bit long. Let's see, we've got a sample of 128 breaks using compound 1 with a specific average and a specific sample for compound 2. Just skimming through here, it says determine the 99% confidence interval for the true difference between the average lifetimes of breaks for compound 1 and compound 2. This, ladies and gentlemen, clearly is a confidence interval, and because we've got two different compounds, two different sample means here, this is section 9.1, confidence interval with two means. And we've got a process for that. We got a highway department executive claims that the number of fatal accidents which occur in her state does not vary from month to month. The results of the study of 152 fatal accidents are recorded. So what we've got in front of us, guys, is a frequency distribution. Okay? It says, is there enough evidence? That's suggesting to me we've got a hypothesis test. Now the question is which section? Well, they don't tell us we've got means and proportions, and there are not two means. So that means that sections 10.2, 10.4, and 11.1 are out the window. That means it's either a chi-square test for goodness of fit or association. Nowhere in this does it talk about variables being associated. Therefore, it has to be section 10.6. And to further understand this, we're given a frequency distribution, and look what she's saying. We're saying that the executive claims that the fatal accidents which occur in her state does not vary from month to month. So that idea of variation comes to us from the 10.6 test for goodness of fit. So that's what this test is, chi-square. Two cards drawn without replacement. Okay, so that means they're dependent. Hope everybody's understanding that, yes? So these are dependent events because it's drawn without replacement from a standard deck of cards. What's the probability of choosing a club for the second if the first card drawn without replacement was a spade? Little key word here. Everybody see that if the first card? This is conditional probability. This is a sneaky one. What's the probability of choosing a club for the second card drawn if the first card drawn without replacement was a spade? This is conditional probability. Make sure you're circling and highlighting that word if. Very, very sneaky. Okay, very powerful word, conditional probability. And that was Chapter 4. How many ways can Patricia choose 4 pizza toppings from a menu of 15 toppings if each topping can be chosen once? This is a counting problem, so you got to ask yourself, does the order matter? Okay, and that determines if it's a permutation or a combination. Again, Chapter 4. Okay, very clearly a box and whisker plot here. We covered these in chapter 3. Very easy to see that. Okay, so make sure you review your box and whisker plots. That's what this is dealing with here. So make sure you have familiarity in reading it. I don't even need to read the problem to know box and whisker plot. Okay, we've got an aptitude test that employees took. So everybody took a different version. Okay, so we've got different scores here. If you read this carefully, the scores are all in different scales, right? So Norma got a score of 66, for example. Nico got a score of 298, so it's hard to compare. Okay, Pierce got a score of 7, right? So they're all over the place here. So if the company's got one position to fill and prefers to fill it with the applicant who performed the best, which should be offered the job? Well, in order to answer this question, since the scales are all different, what we really need to know is how far each of these guys are from the mean. And to do that, you need a z-score. So you got to compute 3 different z-scores for each of the respective candidates and see who is farthest from the mean on the right side. And that's the person who gets the job because they performed better. So this is chapter 3. Can't tell the way the scores are currently. That's why we need the z-score. Okay, we want to classify the data, indicating whether it's qualitative, quantitative, discrete, continuous, etc. That's chapter 1, guys. Okay, more vocabulary for us. Mean cost of a 5-pound bag of shrimps, $50. Standard deviation of $6. Sample of 40 bags of shrimps randomly selected. What's the probability that the sample mean would differ from the true mean by less than $1.3? Okay, so this is probability that the sample mean. This is chapter 7. Okay, and we're given a sample of 40 bags. The differing from the true mean by less than $1.3, that means area in between. So this is chapter 7 because of the sample size and probability of the sample mean and area in between. Plenty of examples of those. Automobile manufacturer wants to know the proportion of new car buyers who prefer foreign cars. Okay, so we're dealing with proportions here. We got a sample. Of those sampled, 142 preferred foreign cars. Blah, blah, blah. Using the data, construct 85% confidence interval. Well, that's very, very specific. We know exactly what we have to do. Chapter 8, I believe section 8.4 specifically dealt with confidence intervals for proportions. Okay, so pretty easy to see there. Publisher reports 68% of their readers own a particular make of car. Marketing executive wants to test the claim that the percentage is actually below the reported percentage. So we want to test a claim that's suggesting to me hypothesis test. So let's see what else it says. Random sample of 140 found at 65% of the readers owned a particular make of car. Is there sufficient evidence at the 0.05 level to support the executive's claim? Oh yes, 100% certain. It is a hypothesis test dealing with proportions. So that's section 10.4. Weights of steers in a herd is normally distributed. Okay, that's keyword. Standard deviation is 300 pounds, and the mean steer weight is 1,500 pounds. Find the probability that the weight of a randomly selected steer is between 1,890 pounds and 1,980 pounds, rounded to 4 decimal places. Okay, so the wording here is we want the probability of a randomly selected steer, not a randomly selected sample, okay? Just one single steer. This is chapter 6. Okay, chapter 6. So there's no sample size. It's just probability of one single steer, one single random variable. And since we're dealing with between, very clear it's area in between. So chapter 6 all the way. Again, you guys had plenty of practice on that if you remember my hand in homework assignment. 2 cards drawn without replacement from standard deck of cards. What is the probability of choosing a club and then, without replacement, a heart? So you heard my emphasis there on the key word and, as well as without replacement. So these are dependent events, okay? And if we're dealing with and, that means you have to multiply probabilities. So this again is chapter 4, using the multiplication rule. So don't forget about without replacement, that changes the denominator, right? Because you're not putting that card back into the deck. All right, we're almost at the end here. The following data is in regard to combined SAT math and English scores, averages by state. What type of graph would you create to display this data? So the states here are the variable, okay? So the states are, in some respect, categories, right? Okay, so you got to think for a minute, what kind of category, what graphs do we use for categorical data? Well, we've got bar graphs and we've got pie graphs. Now we've got SAT averages, so there's not really a way to convert these to a percent, right? Because they're not totals. So I think the bar graph would be the best graph to use to display this data, bar graph. So again, that's chapter 2. Following data represents test scores for 18 students in a class with their most recent exam. Which type of graph would you use to display this data? Okay, so we've got some values here. So this is chapter 2, asking about the types of graph. Maybe a stem and leaf plot would be good, possibly a histogram, because it is quantitative data. Either one of those would certainly be acceptable. Might be better to use a stem and leaf plot because I don't see... A bit harder to get classes. I don't know what the class ranges would be for a histogram. Might not be as significant as a stem and leaf plot. But anyway, that is chapter 2. And determine if the numerical value here describes a parameter or a statistic. That guy's coming to us from chapter 1. Okay, so hopefully this exercise, applause there, special effects. I don't know if the microphone picked that up or not. So hopefully this exercise in reviewing these problems gave you some insight into looking for key words and things. So when you're taking the exam, you'll sort of mimic some of those ideas as well. And so if there's some other tips and suggestions here, you're welcome to review those when you actually view the PowerPoint that will be presented on Canvas. So once again, you've got a good set of 41 problems to go back and review, and that information, solutions, can also be found on the Canvas website.